So what is standardization? Well, standardization is a way of transforming a random variable x into a random variable that would have a mean 0 and variance 1. So let's say we have a variable x that is normally distributed with mean mu and variance sigma squared. How can we transform this variable into another variable that would have a mean of 0 and variance of 1? Well, the first thing we may realize is that, let's say that here's 0, here's mu, and so my normal distribution is centered around mu. Now, what do I need to do in order to make it centered around 0? Okay, well, you can sort of see that if I was looking at x minus mu, my distribution would look something like this. It's just a translation to the left of my entire distribution. Okay, so the variance hasn't changed, but now the mean would become 0. Okay, so this is what we did here. So the first step in the standardization process is just to subtract the population mean, and so we get a random variable that is now distributed with a mean of 0 and a variance of sigma squared. And now to finish the standardization, what we need to do is to divide x minus mu by the standard deviation, okay? And then we will get a standard normal distribution. Now, this final step is maybe a little bit more complicated and requires knowing some properties about the variance. So you can take this as a given, and if you want an intuition for why this is true, you can always remember that the sample variance of x is equal to 1 over n minus 1, and the sum of I is equal to 1 to n of xi minus x bar squared. So here, the squared term would come from the square that you see in the variance. So this implies that the variance of x minus mu divided by sigma is the same thing as the variance of 1 over sigma times x minus mu. And if we consider that 1 over sigma is a, then we can clearly see that this implies, using the rule that I just mentioned earlier, that it's equal to a squared times the variance of x minus mu, which is equal to 1 over sigma squared variance of x minus mu. And now the variance of x minus mu, we said, was equal to the variance of x. That's equal to the variance of x, because as we saw, if this was the distribution of x and the blue distribution was the distribution of x minus mu, they have the same variance, okay, which was sigma squared. So we get 1 over sigma squared times sigma squared, which is equal to 1, okay? So we proved that the variance of x minus mu divided by sigma is 1. So this is how we show that if x was normally distributed with mean mu and variance sigma squared, then z, the standardized version of x, that means that x minus mu divided by sigma will be distributed normally with mean 0 and variance 1, right? Now, you can do the exact same process with a different random variable that might not be normally distributed, and the same will be true. If you subtract the mean and divide by the standard deviation, you will end up with a distribution that has a mean of 0 and a variance of 1. So that's it for today's video, and I'll See you in the next one.